In this video, we're going to digitize a clock dial diagram. The diagram is 16-inch diameter. The first thing we'll do is we'll draw the outer ring, the circle, using the touch 3-point technique. And the computer will echo back the value and will input 16 inches if it's not 16. I like to use tracing polylines. That seems to be my favorite method of tracing. But any other method is fine, whichever you feel comfortable with. The big tip here is to make sure you keep track where you start your tracing and where you end, because you don't want crossed vectors. After you do your trace, the computer will echo back and say, do you wish to join these points? So if you overlap, that will cause a cross vector. I just keep a mental note where I start and where I stop. It turns out pretty good. And again, at any time you make a mistake, just stop, go into the edit section, toggle to that spot, delete it, and redraw it. The diagram is complex and does take time. Now we're going to set up to draw out the movement hole. This is a 3/8 diameter hole. Here I manually inputted the 3/8 diameter. On the diagram, the hole is small, so there are different options for doing a hole. Our diagram is filling in nicely, and like I say, always save your work frequently. If you don't edit out your mistakes, you can always do it later with a third-party software. It took me about an hour to digitize this diagram. And I did have third-party software that I used to edit out some of the nodes where I made mistakes. I'm going to go through the exercise here of setting up the alignment points just in case I remove the diagram off my table and at a later date I want to redraw some stuff again. The file with the alignment points is good to keep just in case. Here I'm marking the 2 alignment points. Now we're into the sizing feature. This is important because we now want to take our 16-inch diagram and make it 39 1/8 inches in diameter. So I'll create this file and then I'll load it into third-party software and check the size. You can see here the size is right on, 39 1/8. We're going to show taking that clock dial file and cutting it on a plasma. I saved the file as a PLT file. The plasma software loads in the PLT file, and we then created the toolpath for all the cuts. You can see some of the lead-in cuts there. He uses a lead-in cut so it won't damage the finished cut on the edges. I always marvel at plasma cutting because you're cutting steel. A lot different from wood or CO2 laser. It's getting close to being completed, so on the final cut, it'll do the outside circumference of the clock dial. And then we're done. I was surprised the amount of time it took us to clean up the backside of that steel. Like 10 minutes. Possibly a bit of sanding and then a paint job. I cleaned up the metal, gave it a quick sanding, and then gave it a couple of coats of silver. We're now going to design a cedar frame to go around that clock dial. Use Vectric Aspire 9.5 to do the design and the toolpath for the cedar frame to go around the metal dial. What's unique here is the size of this project. Ended up that the wood was 49 by 49, pretty well the full size of the width of my table. I fastened it to my slave table using 2.5-inch screws, probably about 7 or 8 screws. I was a bit nervous about the cut, so that's why you can see where I drew pencil lines on there just to make sure that I was going to be cutting in the right spot. I used a 60-degree bit running at about 21,000 RPM at about 100 inches per minute. A quick note here, these videos are all sped up because they take forever. The first toolpath just took the meat out of the letters. The second toolpath cleaned up the letters and made the final cut. You can see here this is the final toolpath on the letters. That second toolpath really spends the time on making up the letters perfect. Now we're ready to cut the inner circle and the outer circle using a 1/4-inch end mill, and I also tabbed it. I had 4 tabs just to make sure that the piece didn't move. The tabs were also 3/8 by 3/8 because I wanted that to stay put. This is a mock-up photo of the frame and the metal dial inside. I'm showing here that I took that file that we drew up and made it a DXF and cut it on the CO2 laser. So in conclusion, we've digitized a small diagram, made it full size for a large clock dial, and I also cut it on the CO2 laser. This was a good project, but heavy to handle.